and you get 5x to the power of a half.
Yep.
And then it's just plus x, plus 3x,
Yeah.
and plus c.
Yeah. We don't need to see. They'll cancel.
There.
Because it's between k and 1.
Does that equal 4?
Something's missing out. This is between k and 1.
So you need to add it to itself again, like 0 add 1 of it, like.
Between k and 1. Any idea what you do with that?
No.
You sub in k for x, and then you subtract what you get when you sub in 1 for x.
Oh, okay. Then you sub in 1, it gives you just the same as before, right?
What do you mean?
Okay.
Like that or something. Yep. Simplify.
So would you get? Would it be 5 minus 5? Would that not work? Would it just be like k?
The easiest way to subtract a bracket is to expand it by -1. But you can simplify what's inside the bracket first.
Oh, okay. So you get 8 to the power of a half.
Power of a half is connected only to the 1. And so you first do 1 to the power of a half.
Okay.
Or just put the whole thing into calculator.
Okay. Which is 8.
Yeah.
And then multiplied by -1 is -8.
Yeah.
And then would you -4 on both sides?
Yep.
Which gives you -12. You
Mm-hmm.
said it's all equal to 0.
So that's -12.
And then the 5k to the power of a half becomes 5 root k.
Yeah. 5 root k, and you just write it exactly as they have it.
Yeah.
That's great. Hence using algebra. How do you do b?
Okay. So do we want to make k the subject for this?
Yep. Basically solve for k.
Okay. So could we use like 5k to the half plus 3k minus 8 equals -4, and then use that to work out what k is?
Yeah, I mean, they kind of wrote it in this form, so they're kind of guiding you towards that, so I'd start with that. Any idea? I reckon
So you would want a -3k on both sides.
No. Let's see. So I'm not a fan of what they did there, but I think they should have left it like that.
Yeah.
There's a little kind of trick, and it's not obvious to spot. Let's say k to the half be equal to a. Let's say u. So what would it become then?
3k plus 5u minus 12u equals 0.
However, k. So k to the half to the power of what gives you k. Yeah, it gives you k to the 1.
Is it 2?
Yep.
So do you want to make it to the power of 2? Like k, just k?
U to the power of 2. Sorry, 3u to the
Okay.
2. Yeah. And so then you'd solve that.
Oh, that's a quadratic. Okay. That gives you u is either 4/3 or -3.
But we don't want u, we want k.
So you would do it as k to the power of a half.
Yep.
And then one of them will be k to the half squared. Alright.
How would you solve it?
You square both sides.
Yep.
And you get 16/9 for the first one.
Mm-hmm.
And 9 for the one on the right.
That's it. That's great. So this is integration. You write it as, so this one is quite common, that it's not 5 over, that the 2 isn't also to the power of a half, and so that stays on the bottom, but the x comes up with the negative power.
Yeah.
This limits between k and 1. That just means, sub in k and then take away what you get when you sub in 1.
Yeah.
It's just the difference between them. If you kind of trying to do part A and you keep getting the wrong answer or whatever, part B, you can just solve this equation.
Yeah.
Because they've told you that that's what it is. It's kind of a hidden one of those quadratic kind of things where you let the smaller one be equal to u and then sub it in. But it's not too uncommon that's k to the 1, that's k to the half, and so if you were to let it be equal to k to the half, then it becomes a quadratic.
Yeah.
Just watch out for it. Okay, how about this?
Would you make wait. Would you make t 0
Well done.
and then solve it?
Sure.
Okay. You get 83 for the degrees.
That's great. B.
This you can make it so it's theta is 35 and make it work, solve it from there.
Well done. 3 marker. Don't just put this into calculator.
So you could minus 18 on both sides. That gives you 17.
Okay.
And 17 divided by 65 is 17/65.
That's great. Any idea how you solve this predicament?
Would it be easier if we made it so it's e over and then like
No.
square root? Okay.
How do you solve it if the unknown is in the power?
Would you need to get rid of the bottom one in the power, in the fraction?
No. So x squared, you know the way you'd like square root it?
Yeah.
Root. If it's 2 to the x, however, you're using logs.
Only to use logs.
Yeah. And you know the way a log has a base?
Yeah.
For this one, because the base is e, you would do log to base e.
Yeah.
And that has a special name. It's called ln.
Okay. Would it just be ln and then would it be nothing else as the base?
So there's a few different ways you can do it, but ln, how can you use that? How can you write this in log format?
Would it be log ln and then...
Just ln.
Okay.
It's just a short way of writing log to base e.
So it'd be ln minus t over 8.
Let's see. So if you were to write it in log format, that's e is the base. That is the way I think of it is you ln both sides,
Okay.
and so you get ln 17 over 65 equals. Any idea what you can do here? You won't know. The power you can bring to the front.
Okay.
Because it's like logs are powers, and so it's index rules in reverse. It's like power to a power, you're multiplying them.
Okay.
And so this is how you deal with if the unknown is in the power, you can log both sides, and then you can bring it to the front. So it was in the power, now it isn't in the power anymore.
Okay.
And then you can solve it. What is ln e?
Is that just 0 or 1?
It's 1.
Okay.
Yeah.
And you get minus t over 8.
Yep.
So you work out what ln 17 over 65 is first, which is minus 1.34117.
Okay.
And then you just times by 8 on both sides.
Yeah. Times by minus 8.
And then you times by minus 1.
Yeah.
Both sides. And that gives you 10.73 to 2 decimal places.
So the 10.7 says 1 decimal place.
Let's go.
10.7 minutes. Okay, C.
Okay. Because there's always a plus 18 on it, so it can't fall below 15. There's always 18 added on.
Yep. And so what's the minimum temperature?
18 degrees.
Yeah. That's it. I just want to look at the mark scheme for part B.
Okay.
So B, yeah. Oops. So they've done ln, that stuff. So you can see method mark and then dependent method mark. So if you just kind of did 10.7 like accuracy mark, you need to get the method mark to get the accuracy mark. B, use the information. Yeah, all right. Let's see. There's a part D, is there? Okay, how about this?
Okay. So for this, so what you just want, is it just a question at the bottom, right?
Yeah, it's kind of strange, but yeah, just the equation of this asymptote.
Okay. So would it be, if it's got a curve, use the derivative?
No. Guess again. Because we can't get the derivative of what we don't know.
Okay.
So let me just compare this to the previous one. Yeah, so the previous one was like theta. So instead of like y equals something x, it's theta equals something t. But it's the same idea. So theirs is like 18 plus 65 e to the minus t over 8. This one is a plus b e to the minus t over 8. But we don't know what a and b are. But it's kind of a similar idea.
Would it be like one of the points on the graph?
Go on.
So would it be like, would you use 0, 94?
Yep,
Because y is 0, x is 0.
sure. How do you use it? Go on.
Would you make a 0 and b 94?
Mu is 94 and t is 0. They're like x and y.
Okay.
So what do you get?
So we don't know what a is either. So we need to work out.
Sublimate.
So you get 0 equals,
94 equals.
or 94 equals a plus be to the power of minus 0 over 8.
Minus 0 over 8. Yeah. Simplify.
Would you need to use ln for this?
Calculator e to the minus 0 over 8.
That gives you 1.
Yep. And so?
That'd be 1 times b, so it'd just be a plus b.
Yep. So 94 equals a plus b. Okay, we've got one equation with two unknowns, so we can't solve it. We can't figure out what a and b are.
Now would you do the same with the other one and make it solve it as simultaneous?
We can try. Yeah, go on.
Okay. So you get 50 equals a plus b e to the power of minus 8 over 8.
Yeah, I was afraid of that would be this crazy thing. Plus b e to the minus... Oh, 8 over 8, is it?
Yeah.
That's not too bad.
Which is minus 1. So make it to power of minus 1. So
Yeah.
e to the minus 1 is... e to the minus 1 is a bunch of numbers. 0.36787944412.
Okay, we'll just leave it as e to the minus 1.
Okay. So we be e to the minus 1.
Yep. Okay, how do we solve these two?
Okay. Would it work if we tried to solve it as a simultaneous?
Yeah,
Okay.
should work.
So we have, for the first one, 1a or 1x plus 1b.
Hold on. They're not too linear, though. Wait, maybe they are. That's crazy enough to work. Yes, this is crazy enough to work. Yeah, go on. Calculator it up.
Okay, so it'd be 1a and then 1b equals 94. And then 1a plus e to the minus 1. And then equals 50. And you get x's, that would be a equals 24.4.
Okay.
And the other one is 69.6.
4, 69.6. And so, what do you do with those?
You want to make an equation with it.
Okay, what's the equation?
U equals 24.4, add 69.6 e to the power of t minus over 8, minus t over 8.
Uh-huh. So we want the equation for the asymptote of L.
Isn't that just straight? We want to know what is on the y-axis, right?
Sure. If we were to graph this one, any idea what the equation of the asymptote would be?
Graph which one?
The previous one. If you were to draw a graph for it, any idea what the equation of the asymptote would be?
Would it be 18?
Yeah, that'd be y equals 18. This one.
So this would be 24.4.
Yeah, y is equal to 24.4 because it can't get below that.
Yeah.
I'm just curious if they wanted an exact, because they didn't say to one decimal place for that part. So part D, anything which rounds to 24.4. Yeah, that's good. Okay. Good. Let's see. So it's basically very similar to the part A, like the original one.
Yeah.
But you had to find it yourself, given 2 data points. Yeah. The asymptote is like what it approaches, but can't get to. So if you, unless you have questions about it, I do next. Oh, come on. There we go. Yeah. Let's try this.
Okay. Would C be 100 minus 180?
C minus 180. This is 3 cos.
Oh, it's 3 cos. Okay.
No, I think you're right. C equals minus 180 degrees.
And then we can use that to solve y.
Sure.
So you put that into the equation. So it'd be 3 cos minus 180, which is minus 3. C is minus 3. D is minus C, sorry.
Yeah. It's great. B.
So for this, would you need to put in x again?
So you basically just have to say how has it transformed. So they'll spot the difference. Y is equal to 3 cos x. Y is equal to 3 cos x over 4.
So x is divided by 4.
Yep. And so what will that change?
It would make y smaller.
It doesn't look like it's going to affect y. Let me give you easy peasy way, because it's I used to try teaching this and it was tricky. So for y is equal to 3 cos x, the x coordinate C was x equals minus 180.
Yeah.
For the new one, what did x become?
X over 4, so it'd be 180 minus divided by 4.
No, look again. So x over 4 equals minus 180. Solve for x.
Oh, you multiply by 4 for x.
Yeah.
Which is minus 720.
There you go. Minus 720 degrees. Part 2.
So would you add 36 to 180?
You sure do.
Which is 216.
216. Probably more to this one. Yeah. Okay. Part C. Hang on. Let's just do a quick sanity check because this is kind of a different skill.
Yep.
So, minus 180 minus 3 minus. Oh, they wanted coordinate. So we just put in minus 3 for both of them at the end. Wait,
Okay.
minus 144. That's not what you said. Why didn't you put in minus 180? Minus 180 plus 36. Cheaters, man. What is that? Minus 144. Okay, minus 180 plus 36. 44. Well, you got the method mark. But they want. Let me. So coordinates. All right. So you just have to make sure you put in the minus 720 minus 3 and minus 144 minus 3. Yeah, 'cause sometimes the thing changes.
Yep.
Right, solve. Why did I make it weird? Okay, let's solve this.
Okay. So, would theta be for cos 450 and tan 720?
No, absolutely not.
Okay.
Theta is between those two values.
Okay.
Just basically solve the equation.
Okay. So do we want to like divide by 8 on both sides?
Yeah, it's kind of the least of our problems, but sure.
Okay. So it'd be 3 cos theta over 8.
I'm not doing that. I'm not creating fractions if I don't have to.
Okay.
Big problem is the cos theta and tan theta. Like if it was cos and cos or something like that, we'd be alright. How do we deal with it if it's a mixture of cos and tan?
Do we want to get just one?
Right? How do we do that?
We could cos divide by sine and give you tan. Or is it sine divided by cos that gives you tan?
Yeah. So that's a step in the right direction. Okay, go on.
Could you multiply by cos on both sides?
Yeah. What do you
That
get?
gives you 3 cos squared theta squared.
Cos squared theta only.
Okay.
And we put the squared before theta to show that it's like the whole thing squared, not the little thing squared. Okay. Any idea what is next?
No.
My guess, it's not a good one though. My guess is, might be the easiest way. So usually the way you can swap between sine and cos is like sine squared plus cos squared equals 1.
Yeah.
You could square both sides.
Okay.
What do you get?
You get 64 sine squared theta, right?
Yeah.
And then you get 9 cos to the power of 4.
Yeah.
Easy.
So how do we solve this?
Could you divide by one of the numbers?
You love dividing. That doesn't solve our problem of a mixture of sine and cos.
Okay.
Now change sine into cos.
Oh, would you make it called sine squared minus 1? Or 1 sine squared?
So sine squared theta plus cos squared theta is identical to 1. And so what is sine squared theta? Same as?
The same as 1 minus cos squared.
Yeah. So
you make it 64 at the outside, and then would there be a bracket? Yeah, 1 minus cos squared theta.
Well done.
And then would you multiply by everything in the bracket?
Yeah.
Gives you 64 minus 64 cos squared. 64 theta.
Yeah.
Could we minus 64 on both sides?
Yeah.
And that gives you minus 64 9 cos. Okay, let's do it that way. Yeah. Minus 64 equals.
Yeah. And then?
Equals minus 64 cos squared theta.
And then? So we move to that over.
Oh, use calculator.
Yeah, but move them both over. So I'll make it equal to 0.
Okay.
Yeah, okay. Calculator it up, what do you get?
Okay. How do you make cos to the 4 and then put theta on the right? It doesn't let you.
No, we're all right. So let's say remember we let the smaller one be equal to something?
Oh yeah, so it'd be like you cos squared would be like u or something.
Yep.
Yeah.
So what do you get?
You get 9u squared theta.
No.
Oh no, cos theta is also u. Okay. Plus 64 u minus 64.
Yeah.
And then you can solve as a quadratic.
Mm-hmm.
So you can either be 8 over 9 or minus 8.
Minus 8, okay.
And then you want to square both of them.
No. We want cos theta. We want theta.
Well, u is cos squared theta, so we'd make them equal to cos squared theta.
Yeah, so we just did that to help us to solve it, and now we just swap it back to what it originally was.
And then could you square root both sides?
Yep.
Which gives you 8 over 9 square root, which is 2 root 2 over 3.
Mm-hmm.
And then square root of minus 8 is a math error.
Yeah, can't square root a negative.
Yeah. So there's only one answer, right?
No.
No, it's 8 square rooted.
No, hold on. It was... How many answers are there for this one? X squared equals 9.
There's 2 answers.
Yep. Plus or minus.
Yeah.
So cos theta equals square root of 8 over 9. Was it 2 root 2 over 3?
I'll check again. Yeah, 2 root 2 over 3.
And so what's the other answer?
Minus 2 root 2 over 3. What do you need to, if you wanted theta, you need to inverse cos on both sides.
Well done.
Which is, for the positive, it's 19.47.
Oh, 19.5.
Yeah. And for the negative, it won't work. It would just be negative.
Well, negative 19.5?
Yeah.
Sounds like it does work. Okay. However, we want the answers of theta that are between 450 and 720.
So we need to add a 180.
Cos doesn't repeat every 180.
Was it tan that repeats every 180?
Yep.
So
Hold on. So
is it 360 for cos for the first one?
yeah. Hold on. So these are your first answers by doing arc cos. Second answer for cos, do 360 minus first answer.
Okay. And you get 340.5.
And the other one?
Wouldn't that be adding double negative?
Yep.
It is 379.5.
Okay. And so now we have these four values.
And then can we add 180 to them?
We could if it was tan. Tan repeats every 180.
And do 360 again?
So you just, from now on, you just add 360. It repeats every 360. The 360 minus thing is just a kind of a coincidence.
Yeah.
Like with sine, it's 180 minus.
Yeah. So for the first one, it's 700.5.
What did you add? 360?
Yeah, 360 added on to that.
This bottom left one, is it?
Yeah.
Say it again, 700?
700.5.
Okay.
And the other one is 739.5.
So that'll be outside the range.
Because it's over.
Yeah.
So our answers 340.5, 379.5 and 700.5.
340.5 is too low.
Oh yeah.
So these are too small, but they'll repeat every 360. So add 360 to them.
Wait, add 360 to which ones?
Like 19.5 minus 19.5. All of them.
They'd still be too low ones if you added 360 to them.
So add 360 again.
Okay. So you should do 720, add to those.
I see what you're saying. Yep.
So for the one on the left, it's 739.5, which is over.
Uh-huh.
And then for the one on the right, it's 700.5.
Is it 700.5 as well?
Yeah.
Uh-huh. Okay. And so we're just getting one answer, which is 700.5?
Yep.
Huh. Yeah. Look at that. Your solution. One solution. Okay. Let's see. So 520.5. Where did it all go wrong? Sine over cos. Sine squared cos squared is 1. I'm not sure where we went wrong, to be honest. Hopefully your calculator was alright. Hang on.
Yeah, it was.
So I did this sine squared thing. Hang on, I want to see. They seems to have used a simpler method. So we went to the power of 4. They managed to avoid that. Let's see this one. 3 cos theta equals 8 tan theta. Yeah, 3 cos squared. Oh, that's much simpler. That's much simpler. You know how we changed sine squared into 1 minus cos squared?
Yeah.
At this point here, see the red part?
Yeah.
They changed cos squared into 1 minus sine squared.
Oh, okay.
Oh, that's much simpler. Okay, let's just say. So forget this, the red squared. So change that into 1 minus sine squared. What do you get?
Does it change the cos to be 1 minus 3 cos 3 sine squared?
So that's just 3, 1 minus sine squared theta. So we expand that.
Yep.
Bring them onto one side. So what is that in the calculator?
Okay.
Oops. A third and minus 3. And so sine theta is equal to a third, or sine theta is equal to minus 3. So what would you do next?
You do inverse sine.
Yeah.
Of a third, which is 19.5.
Yeah. Wait, 19.
And then inverse of minus 3.
Theta is 19.5.
And then it doesn't give you an answer.
Ah, so that's outside the range.
Yeah.
So we get 19.5, which is the same as what we got for our one.
Yeah.
How do you get second answer for sine?
You add 90, right?
180 minus.
Okay.
So cos is 360 minus.
So you get 180 minus 19.5, which is 160.5.
60.5. And then we want the answers between 450 and 720.
So can we add 360 to it?
Yep, to both of them. As many times as you need to.
Okay.
First answer is arcsine. Second answer is 180 minus.
So you get, for the bottom one, 520.5.
Okay.
And then 360, add 19.5, which is 379.5.
379.5. That's too small.
Yeah.
379.5. And if we were to add 360 again, it'd be too big. So it's just 520.5.
Yeah.
Let me see there one. 520.5. So I think we just because it got so messy, we just kind of went wrong somewhere. With some kind of calculation. But let me just put that somewhere. Yeah. If you have to change between sine and cos, cos squared is 1 minus sine squared is 1 minus cos squared.
Yeah.
So actually that would have been easier than going to the power 4. Okay, that's good. Okay, how about this?
Okay. So would you need to factorize?
No. Factor theorem is the quick way of doing it.
Okay.
So if you had some function and it's like, so g of x. So g of x is equal to, if it was in factorized form, so let's say you did factorize it and you've got something like that.
Yeah.
What would you sub in to get an answer of 0? Let's say this is equal to 0. Solve for x.
Well, you said what do you need to get 0? You need 0 to get 0.
Or just solve for x. Like, what would x have to be for you to get 0? So like with
5, it just needs to be 5.
Yeah, like with GCSE, you've got 2 brackets. So
Yeah.
x equals 5.
Yeah.
And so you would show that it's divisible by x minus 5 by subbing in 5.
Yeah.
And so sub in 5.
Okay. Which is 0.
Last thing you have to say.
X is divisible by, well, gx is divisible by x minus 5.
Yeah.
Because it's equal to 0.
Yeah. Therefore, it's divisible by x minus 5. Yeah. So just like with this up here, if you were to sub in 5, you'd get 0. If you sub in 5, you get 0. So x minus 5 must be a factor.
Yeah.
B.
When it says 3 linear factors, does that mean it wants 3 answers?
Not roots, not solutions, factors. So one factor is x minus 5. A solution is x equals 5.
Okay.
So factors means brackets in this
Okay.
case.
So could 1 be like x plus 5?
No, well, maybe, but 1 is definitely x minus 5.
Okay.
We just showed that x minus 5 is a factor. Fully factorize.
So you want me to factorize the equation at the top?
Yep. How do you do
So would you want it would have like 2 on the outside of the bracket?
No. You're just factorizing it. So one bracket is x minus 5. You have to figure out the other bracket. I'll show you how to cheat. Right.
Okay.
Calculator. Solve it.
Do you want me to make it x equals 2x cubed plus x squared minus 41x minus 70?
I don't know. Solve it. Calculator. 2.
Okay, so you get 2x cubed 1x squared minus 41 minus 70. And you get, it can be 5 minus 2 or minus 7 over 2.
Okay, x equals 5, so that's what we were expecting.
So you'd make it x plus 2
Yeah, so one
and
bracket.
x plus 7 over 2.
Sure, hold on. Don't give the game away just yet. X minus 5, x plus 2. However, they have to be factors. They can't be fractions. So x equals minus 7 over 2. How could you get rid of fraction?
Multiply by 2 on both sides.
Yep.
and then that'll become 2x minus.
2x equals minus 7?
Plus, oh, it'd be minus 7, yeah.
Equals minus 7. Okay, go on.
2x plus 7 in the brackets.
2x plus 7. All right. That's the correct answer, but we didn't do any working out. Expand the second two brackets. What do you get?
2x squared.
Yep.
Plus 7x. 4x plus 4x. Plus 34.
Plus 14, isn't it? Oh, sorry. That's just a 7.
Oh, it's okay.
It's a plus.
14, yeah.
I'm just don't have much space. Simplify. Simplify right bracket.
So would you need to multiply?
No. Simplify the right bracket.
Oh, okay, so it'd be 11x plus 14 in solve as a quadratic.
We already did all that. 11x plus 14. Okay. What have we done here? We've written it in reverse order and pretended we did it in this order. So Mr. Examiner looks at our thing. So we know x minus 5 is one of the brackets.
Yeah.
The other bracket, well, you can just kind of logically see it. So if you had x minus 5,
yeah,
you can see the other one will have to be 2x squared. You can see the last number will have to be minus 70 divided by minus 5, which is 14.
Yeah.
And then we have to have some number in the middle. Let's say we did it in our head and we got plus 11x.
Yeah.
Then we split that into 7x and 4x. Then we factorized those. And then that's the question finished. And then, I'm a silly student. I actually went and solved it and I didn't need to do that. But you ignore everything after the working out. Let's just see what Mark Scheme has to say. Let's see. And it's a factor. So attempts to factorize the quadratic for the method mark. So the method mark, you have to have x minus 5 and then some other bracket with the 14. Accuracy mark is the actual correct bracket.
Yeah.
And then some attempt to factorize the quadratic and then the fully factorized thing. And they'd ignore any working out after that. The easiest way to do it is to just solve it in the calculator and write it in reverse order. So x equals 5, so it's x minus 5. X equals minus 2, it's x plus 2.
Yeah.
And then the other one has to be whole numbers, so you get rid of the fraction. But to pretend you actually did that forwards, you need to expand those two brackets and do it that way. The other way to do it is to actually do it up the way that's done this way. So one is x minus 5, and then the other bracket would be 2x squared at the start. It would be plus 14 at the end, and then you would figure out what goes in the middle.
Yeah.
And then you could put into your calculator 2x squared plus 11x plus 14, and you get the two factors for that, and then factorize that.
Yeah.
That's how you go with that. But anyway, that was C. Hang on. Why is it showing me a part? Oh, there was an integration thing. The finite region R is bounded by the curve and the x-axis. Find using the exact value of the area of R. I think that's just integrating.
Oh, that's been integrating the top equation.
Just integrating the top equation. That's not too bad. G of x and the x-axis and lies below the x-axis. The exact value of the area R. All right, integration isn't too bad. We'll be alright with that. Let's just see. So that was the last time. Yeah, so sometimes you have hidden quadratics. K to the 1 is the same as k to the half squared. So let k to the half be equal to u, and that's how you can solve these kind of square root questions.
Yeah.
Let's see. Sub in t, get that. Yes. How do you solve it if the unknown is in the power?
You need to use logs.
Yeah. And if you have e, use a special log, which is ln, because ln base e becomes 1. Sorry, ln e is 1. And the reason why you use logs is because you can take it to the front. So it goes from being in the power to not in the power.
Yeah.
Which is what you want. This asymptotes business. Just sub them both in and it's simultaneous equations, basically.
Yeah.
That one was okay. Yeah, this one just, it's kind of like it's been transformed. So you spot the difference. X became x over 4. And so x equals minus 180 becomes x over 4 equals minus 180. And, you solve it. Then this one, the heartbreaker. Yeah, cos squared changed to 1 minus sine squared, or sine squared changed to 1 minus cos squared.
Yeah.
And it's a quadratic. And then this one, calculator, work in reverse. Yeah, how was that for you, Adam?
That's good.
And so, more exam paper stuff next time?
Yeah.
Okay, any questions for me in general?
No.
Alright, well done, Adam. You did great.
Thank you.
I look forward to talking to you again next time.
You too. See you later.
Alright, have a nice weekend. Bye bye.
You too. Bye.